to give you the promo of the promo is that your game is on. Like, this is where it gets a little deep, so you really got to make sure that you pay attention. So what we're going to be talking about right now are power series. Power series. What's the only real difference between you've done this reading, so you might be able to answer this question. What's the only real difference between a power series and a geometric series? What are the main differences, James? What's one of the differences, James?
The ratio is variable.
The ratio is the ratio is variable. In what way is the ratio variable? There's some consistency to it, right?
And the variable is it's x minus a.
Exactly. So our big thing here is now, instead of having a ratio that's going to be 1/3 or x, our ratio is going to be x minus some constant. Now, not only is the ratio going to be different because it's x minus a, what's also hovering out front there? The C0, the C0, C1, C2. Now, are those things necessarily always going to be the same? No, not at all. Like before, we had a, and then a times x, and then a times x squared, and then a times x cubed, and a just kept on going, right? Is there necessarily going to be that type of clean relationship between the C0, the C1, the C2, the C3? Not necessarily, no. How do you say this out loud? I said it once, but do you know how to say that right there? Yeah, C, and I'll give you, besides the editor of our school paper, can anybody spell not for me? SAT question, kids.
N-O-U-G-H-T.
Say what?
N-O-U-G-H-T.
Close. Is it N-O? I don't think it's N-O. N-A-U-G-H-T, right? And it, see not. Anybody watch the spelling bee, the national script spelling bee, where you get to look at kids that make you seem like you've done nothing with your life? And then you realize they've only studied 9 hours of vocabulary every day of their life since they were like 0 years old. So that's see not. And not means nothing. It's all for not. Okay. Oh, you got it now? Just amazing. Epiphany time. Okay. So this kind of this right here, this is just a definition. This isn't any something we have to prove. But the idea is for a fixed value of x. So the thing is, this series can change depending on what x is. X can be a lot of different things. For a fixed value of x, if this sequence of partial sums converges to a limit, that is, if the limit as n goes to infinity of Sn of x equals L, then we say the power series converges. So if for some value of x, this power series converges, the sum converges to something finite, then we say it converges to L, then we say that it converges. That's just the statement of basically if it converges, it converges. But how do we prove that one of these converges? We look at the limit as n goes to infinity of what's Sn, the partial sums themselves. Okay, so the thing about this is, and you should have read this, is that for power series, there's 3 different cases here. A power series might not ever converge. A power series might converge for all values of x, or a power series might converge for some part of the real numbers. And when I say all values of x, I mean like all real numbers. So it's either all real numbers, some range of x, or actually some specific values of x. It essentially gets back to this. One thing you'll notice about math, well, not math, but in terms of numbers of answers, generally you see there's 1 of them, there's 0 of them, or there's an infinite number of them. And there's kind of 2 kinds of, there are actually types of infinity here, but you're either going to have all real numbers, but how many numbers exist between, say, 2 and 4? There's still an infinite number of numbers, but it's a more limited region. So we've actually seen this in other cases. This right here, this is a power series right here. Here it is, this power series. Does it converge for these specific values? So if you're going to examine a power series for a specific value of x, this is functionally equivalent to what we've done before. James, please stop typing. This is functionally identical to what we've done before, which is we're plugging in the value for x. We're going to generate a series, and then what do we get to use to see if it converges or not? All the different convergent tests that we have. If we're plugging in a specific value, all we're doing is testing for a specific power series. So let's actually do that for one of these. Let's actually do that. And so let's plug in -1 into this. We end up with the sum as n goes from 0 to infinity, and that's a really thin one, so let me get to a bigger one here. Can you shut the door over there? That'd be great. Thank you.